Hi, welcome back. In this video, I'm going to finish the discussion of the new Python functions that you've learned in section 1.3. So we started off with rectangles, ovals, and circles, and lines, and we'll finish with this video, which will cover labels, polygons, and stars. So here we are back on the word processing version of our canvas, just to demonstrate an idea. In order to use the label function, and you might understand the label function actually as like a text box essentially, you get to control all of the things about that label or that text that you're going to include in your drawing. So its size, position, color, whether it has a gradient, a border, and so on. So all of those program parameters that you used in rectangles and ovals will mostly apply here as well. So first we need a location. Where do we want our text to be? And so I've got a dot here. So all this dot does is represent an XY address. Now you would think that this would be the starting point of your text label, but it turns out that this is the position at which your text is centered. So we just need some text here. I'm going to go grab some. I'm just going to move this little text box up here. So the idea of the label function is that it's going to take your text, whatever is typed in between the two quotes, and it's going to center it horizontally at that address. That's it. That's the label function. So we'll be able to control things such as the font and the font size and color, as well as whether it's bold or italic. So those are true-false type features that we can turn on and off. And of course we'll be able to change the border. So if you wanted to have like block letters, we could set the border to a color and the fill equal to none. So it would be basically a hollow shape. That would be interesting. And we can also have gradients. So all of those things you can play with in the exercises. So back in the coding window, let's go ahead and print up a label. And I've just got some comments here. We're going to print out the string hello world. We want it centered in the center of the canvas. It's going to be bold, italic, in a Courier font, size 36, and it's going to have a yellow progressing to red gradient. All right, so all of that is one big honkin' command. Let's go do it. In order to save time, I have this already all typed out, so I am just going to hit Control Paste so you can see what this command looks like. And you'll also notice that instead of putting this all on one line, I've, just for demonstration, kind of broken out all those parameters. The important thing is that we have an opening parenthesis here, and the closing parenthesis is indicated by these matching squares. So that's kind of nice. This is a nice feature. When I click on this paren here, it attempts to find for me the matching closing paren and put a little box around it. This is an error that occurs frequently in Python, just mismatching parentheses. So all of the things that we wanted in this label are here. The text, the location. We're going to turn on the bold and italic parameters. We specified the font, we specified the size, and we specified the fill type as not a solid color but a gradient from red to yellow. So if we run this, that's what we got. So I would say the secret to becoming proficient at using these is just literally to practice them. So as we're growing the number of tools in our toolbox as we write programs in Python, you will not always remember all of the parameters, all of the structure of each command. And yes, you will need to go back and have a cheat sheet in a sense from time to time just to remember, hey, how do I do that? You'll remember that you've done it before, that you can do it, and may not remember exactly how. That's going to be easy to fix. The next item to cover is section 135, which covers regular polygons and stars. So it's important to know some geometry here And it's okay if you haven't taken a formal geometry class. I think you'll understand very intuitively everything that's in the background here. So the idea here is if someone said, hey, on a piece of paper, draw me a polygon, and assuming that you know and understand a polygon is a closed shape with sides made of line segments. So we think of triangles, squares, hexagons, octagons, and so on as polygons, closed figures made up of sides that are straight lines. So I think you could easily draw some shapes. If someone said, hey, how many sides should there be? They can specify. In this case, I think there's 8 sides. In this case, there's 5 sides. So drawing polygons is quite easy. But here we are constructing what are called regular polygons. Now there's something in addition that must be true here. So regular polygons have a center, just like a circle, and the lines that are drawn from the center to every corner are all the same length. That's what makes a polygon regular. So you can see that this shape is not regular because the lines that connect the center of the shape to all the different vertices, they're different lengths. And same thing with this pentagon here. Alright, so with that understanding, it should be clear that we only need 4 things to specify a regular polygon. The first 2 things are its center location, XY address. The third item is the length of the radius, which is consistent. And the last item is, well, how many sides do you want there to be? So just take a look for a moment. There are 6 sides in this shape, but that also means that there are 6 vertices or corners where we change direction. So it's those line lengths from the center to the vertex that are the same. So let's go ahead and draw that same polygon, the hexagon, that we just saw a moment ago in the Python canvas. So that would be the regular polygon command with a center of 200, 200, radius of 50, and we want there to be 6 sides, which makes it a hexagon. So there it is. Our default color is black, so we can of course change this to anything we like. I like cyan. And we can also set a border there. Set the border color to black. So the next item is to draw a star shape. And I would say that a star shape essentially starts out as essentially a regular polygon. And all we have to do is connect the vertices to see the star. Let's do that here. It only takes a few lines. So I'm going to insert some lines and just start connecting vertices on this regular 6-sided polygon that I have here. Maybe we can see a star shape. So I got to do this like, let's see, 4 times. Insert. Alright, so I did fast forward that process because there's a lot of diagonals to draw, but I think you can see the idea of the basic regular star shape here. So we'll just start here. I'm just going to traverse this thing. There's a star. There's the 6 different points to the star. And if you start off with a regular polygon, these petals on the star will all be exactly the same. So I just wanted you to see here that a star starts off with the same idea as a regular polygon. Let's go see this in code. So here in the Python canvas, we're just going to start off drawing a regular polygon with a center at this XY address. It's going to have a radius of 75, and it's going to have 5 sides, and we're going to just make it a light blue color. exactly what we expected. So right below that, in other words, on top of this blue pentagon, we're going to create a star shape. And the star shape is going to have what's critically important here is the same center, 200, 100. So our star will be centered exactly the same as the polygon. And if we specify the radius also to be the same, and the number of points on the star to be the same, then we should get in this case, a default color black star overlaying inside of this polygon. Now, as it turns out, there are other 5-pointed stars that are regular that we could easily draw. And so in Python, at least in this function library, we're allowing you to change the look of this 5-sided star by changing what's called the roundness parameter. So roundness is a value between 0 and 100. And let's just play with a couple of these. Let's pick a small number, a medium number, and a high number just so you can visualize this. So here a roundness of 10. Here's a roundness of 50. And a roundness, let's go to 90. Okay, I think you see the idea. So just use this as needed or as needed, required in your projects. The last case covered in section 1.3 is to construct just polygons. So distinguish this from what we call a regular polygon, which had all those side lengths the same. In the case of constructing a polygon, all you need to do is just define all of the locations of those vertices. So if we connect the dots literally with straight lines, so there are 4 dots here, and if I connect these with straight lines, there will be 4 straight lines, and it will define an inside and an outside of this shape, and that is a polygon. So here I purposely overdrew the straight lines that are connecting the 4 dots or the 4 corners, just to remind you that the sides of polygons are line segments, and a line segment is just a piece of a line that kind of technically goes on forever and ever. All right, so you can clearly see we have an outside region and an inside region. So drawing polygons is going to be useful whenever you want to construct a closed shape that is not regular. So here I'd like to show you why using the canvas would be useful. If I was trying to recreate that image that I had, so these 4 locations here, if I look at the canvas, I can see in the lower right corner a running presentation of the current XY location that your mouse is at. So as I move the mouse around, you can see these all shift. So I can position those 4 locations, just again using your eye, so I can get a close approximation of that random drawing that I just drew in Microsoft Word. So creating that estimate just by moving my cursor around, I chose these 4 pairs of points, 40, 60, 20, 160, 160, 180, and 260, 80. So those are 4 points, and if I use this polygon tool to connect them, it looks something like that. And that's pretty close to what we had before, I think. Not bad. Just remember the polygon tool can be used to construct any irregular shape as long as it's made up of line segments and creates a closed figure. Well, students, that concludes this tutorial. What you have left in this unit is to do the exercises. Now you have to go back and do those for 131, 134, 136, etc. Then there's unit exercises here, and you have to select some to get a total of 8 points. And then your final task here is, these are optional, by the way, these challenge exercises. You do not have to do them. But you do have to use one of these creative tasks. So understand these are samples here. So don't actually draw these. They're just meant to give you an example. What you do need to do, which we'll talk about more soon, is select one of these creative tasks and build your own.